joining us
Yeah.
from Michigan.
So
Take
it's
it
a
away.
nice year. Thank you for your introduction. So I'm Herman, and I just joined last year. So technically not just joined, but this is my second year at Michigan in the Performing Arts Technology. So that's under the School of Music, Theater, and Dance. And somehow today I'm going to talk about one of the our ongoing work, AI-assisted video editing. And at the end of the talk, you will somehow see how that connected to some of the future goal, I think, in music that could be potentially very useful. Cool. So just a brief overview of what I've my research is about. So I do I guess the overall theme is about augmenting human creativity with AI, and I've been working on different types of research. So one of the first thing Anna mentioned is thinking about what are some of the novel generative models for new domains. So at the time when we are looking into how to use like generative neural nets for creating music, we're thinking about how we can generate music in a way different from the past work, because people haven't been thinking about generating multi-track music using deep learning model. So that's sort of like the first model that's trying to dig into multi-track, polyphonic, real complex music generation. And I've also done a lot of work on AI-assisted tools for content creation, mostly music. But recently, I've started a bunch of work on video editing. So that includes violin performance synthesis, using instrumentation, arrangement, harmonization. And recently, we've started a very exciting a cappella source separation model work that we are basically trying to build this source separation model so that in the end, what we want to do is to build a vocal app, coach app, so that help a cappella singers to practice, along with the recording from their rehearsal.
Wow.
And finally, we have like all the multimodal generative models for content creations. I've done text query, sound separation, text audio synthesis, text to music generation, and more recently video to music generation. And the topic that I want to talk about today, long to short video editing. Cool. So let's get started. So video editing, this is different from likely what you will come into your mind about AI video editing. So this is not about the image of editing. We talk about mostly in computer vision, where we are thinking about you have an image, you try to edit part of the content inside. But rather here we are talking about how video editors are composing these longer videos. How do you grab different clips and then put them into different places, but still the overall should convey a cohesive story. So think about the typical way how video editors will create videos. There will be a bunch of different videos. Think about interview footage. In this case, this documentary is about this lady's story. So you will have a bunch of interview footage of that particular subject. But at the same time, there was also background footage, where they're from, what's the circumstance, and what are the context, what are the topics concerning about. And there will be activity footage that will basically tell you about what's going on in this documentary that we are going to see. And finally, there will also be a bunch of interview footage for other subject involved. And so as you can see at the top, this is like a typical think about film, think about documentary, think about different type of videos, or think about news that news that there's someone talking about something, and then they will grab real footage to increase the factuality, but at the same time that's the real stuff that's going you are commenting and providing a cohesive story on top of that. So that's what we'll talk about today. So you can see that yeah, somehow it's a little laggy. But anyway, you see that you will have a bunch of footage, but now the idea is how you together compose a story on top of those. And there's this fast growing short video platforms. In the past, video editors are looking at YouTube, Twitch, Bilibili, Vimeo, Dailymotion, Nico. So many different video platforms. That's for long form video platforms. But nowadays, content creators are also looking into YouTube Shorts, Instagram Reels, TikTok, Twitter, Snapchat. So, nowadays, for content creators, people tend to, try to create the same content, but in different formats, in different durations. So that's exactly what we want to investigate in this sort of like first step toward, the eventual goal of AI-assisted video editing by starting from generated shorts from long videos. And to provide a bit more context why this is important, so for content creators that help promote long video content, so that's exactly what we were seeing here, that you have a YouTube video that's a very long story, but at the same time, it's a big time investment for the consumers. So you want to make it into much easier engaging, like a teaser, trailers, so that to promote your content. But for content consumers like ourselves, if you're going to YouTube looking at these content, it helps digest information in a more engaging way. And later I will also show an example of what I'm seeing in the future. What this could potentially build a very interesting lecture recap app. That's an idea that I always wanted to do, but I'm still looking for ways to do it, get some funding, but hopefully we'll get it done. Cool. So today I will basically talk about two sort of like serious work that we have been doing on long to short video generation. And actually the project is led by Wei-Han. She's here. She's currently working with Paul in Media Lab. And so to be honest, the two work is led by Wei-Han. So I'm more like, just talking about it, but sort of like give you some of the larger context of it. But, most of the work are definitely led by Wei-Han. Cool. So this work was published earlier this year in iClear, and a bit shaky in the review process because we are actually proposing a totally new task. And this task is generating teasers for long documentaries. So that's our first step for working toward AI-assisted video editing with generated shorts for videos. So this is just an example of what our data set is like. I will show you why we are doing documentary, because that's essentially sort of like the only way we can get a bunch of teaser and full body content easily. Hopefully there's no ad. Okay. I'll never fix that. We can figure out the sound.
Maybe I need to choose the audio.
So I should mute myself, but I.
Egypt, the richest source of archaeological treasures on the planet.
Oh, that's a fabulous one.
Okay, that's very, very laggy. But anyway, hopefully. So anyway, lots of these documentary on YouTube, you can see that actually at the very beginning, there will be a very short, like 1 to 3 minutes overview of the whole teaser, just to get you started. So if you have seen Netflix, it's sort of like when you hover onto some video, and it will show like a trailer or a teaser-ish thing. So this is essentially how we get this data set, and that's our first goal of getting this data set so that we can analyze or teach the model to learn how to go from long video and cut them and rearrange them into a shorter teaser. Because this basically assumes that most of the content or the materials for that teaser is coming from the longer video.
$15 a month.
Olive Garden's.
I think our life will be very harsh for video through Zoom, but hopefully, I guess there's no way out. So anyway, so in this work, we were trying to do this documentary teaser generation. I guess I can show you what I meant by that first. So this is typically what you get on YouTube. So you'll have a video that's super long, but there's somewhere you will see something like this. There, some text popping up that basically shows that this is when the full episode episode started. And so that's essentially how we get this pair data. And you go to YouTube, you grab a bunch of documentary. What you need to do is to see where that boundary is. And now you get a pair of body content and the teaser. And what you want to do is basically, thinking about, can we go from this body content, which is 30 minutes-ish, to a shorter version of 1.3 minutes. So that's essentially what we want to do in this case, which is around 24:1 compression ratio. Cool. So now we put it back to where we were at. So this is a little bit different from if you have been working on a little bit like video summarization, your highlight detection, or think about movie. It's different. So first, unlike video highlight detection, a teaser needs a cohesive narrative. So think about video highlight detection. You just grab those highlights and put them together. There's no connecting information to make it a cohesive narrative. And it's also different from video summarization. Teaser need to be interesting and engaging. And typically a documentary teaser, the goal is to have them to watch the full episode. So the short video, the whole thing about shooting short video, especially when it's paired with a long video, the goal is to drag the consumer, the audience, into watching the full episode. It's a little bit different from video summarization. And it's also like movie trailer. This we will see later why this is important, because documentary is different from movie in that movie is more visuality for most of the part of the movie. But for documentary, it's been more narration focused. There's a lot of narration, there's a lot of interview, lots of the information are being conveyed through the speech, through the text, through the information that's being spoken up from the subjects. Rather than a movie, sometimes you're describing how the characters interact with one another. It's visual language rather than specifically speaking out those things. And finally, documentary teaser needs to preserve the factual accuracy. So this is very important. And we'll see in the next project how we can actually do this by grabbing actual footage from the documentary to do that. So as I said, this is how we get our data set. It's very tricky to get any kind of these pair data set. Think about how on the Earth you will get a video and it's like shorter version, and how do you even pair that? But with all these YouTube documentary channel, we sort of get free data easily. There's like teaser at the beginning and the whole body content in the later. So that's essentially what we built at the first. So we will do this like documentary math. It's a new data set for documentary. So it's like 689 hours. So it's very long, very big. It's like 1,200 high quality documentaries. And you have the teaser. The average length is like 1.3 minutes. So usually like 1 minute to 3 minutes, but that's a short teaser of the full body content, which on average is 30 minutes-ish. Cool. So you can get a sense what it is. And we are grabbing the data from 3 reputable sources: PW, PBS, and National Geographic. So you can get a sense what the data set is like. You have the title. There is also user annotated text where you can find on YouTube. And more importantly, you can actually just use Whisper by OpenAI to get the narration with timestamps. So then you get all the timestamps and what's the the sentence that's being spoken out in the narration. And also for the interviews, not just the narrations. Cool. So that's essentially what we are trying to do. We want to, look at this body content, try to cut, try to rearrange, try to remix into the teaser. And so this, in this project, different from the next project I'm going to talk about, but in this project, we are thinking about, more from a narration-based scenario. So essentially it's narration-centered. So look at this pipeline now, it might seem very naive, but that's sort of the way how we get started. So think about it this way, where we have all the body content. You have a very long, like 30 minutes-ish video, and you have the audio. And thankfully, now we have a very good ASR, so speech recognition, so that you can get all the narration. So now it just becomes sort of like a text that you can edit. And what you can do is think about you're generating the teaser narration rather than generating the video itself directly. So you are essentially leveraging the the powerful summarization capability of LLM basically, so that you can say, well, this is the full episode with all the context. How can you summarize it into a shorter format? And then you just use text to speech to synthesize this. And then finally, what you want to do is that, well, for each of these teaser generated, which is much shorter than the original body content, but now you still have a bunch of sentence. And now the goal is to see how you can grab the right images or visuals to pair with the audio that you just generated. And so that's essentially what we're trying to do in this work. Questions so far?
Yeah, I'm just wondering, like, whose voice do you use for the text-to-speech synthesis?
Randomly choose one. Yeah, for now it's like that, and I guess in the end it's like you can choose. But that's the same in documentary. Usually the narration is the same person. And it actually creates some issue in this case is that, well, all the way it's the same person talking about it. But in the next project, we will see that, if you can insert some of the interview clips, that's also how in the documentary make it more fun, more engaging, because you will have different voices. And so like, the way how people have been shooting documentaries. Yeah.
Which steps are learned?
Which steps? Mostly the narration matching part. That we will go into details later.
So based on this approach, it seems like the video component, the visual video component seems to be taken from the original body. But I'm wondering, for the audio, do you keep or splice parts of the original video, or is it entirely audio AI generated?
Yeah, for now it's just the speech, and that's a very, very good future work that we are looking into. Is that we have the body content. There are also sound effect tracks and the music tracks. The track, and so we are now basically discarding those, which is sad, but that's how we focus the scope in this project. In the future, I guess later we see, I guess the final idea is about, can you get a blueprint or the storyboard where you put the sound effects back and the music back to support the whole story that you are talking. But for now, it's just narration in this case.
Thank you.
Cool. So yeah, as I said, narration video matching will be the core learned thing in this case. So for other part, mostly we are using pre-trained, pre-trained ASR, pre-trained LLM, just do some prompting that could better generate a better narration for the teaser, and TTS is also pre-trained. Cool. So, well, we still need to do some prompting for the narration, because at the time, LLM is not that powerful enough. But basically what we've done is a little bit like prompt engineering, but I will just go through it. Just take a look at it. So we break the full narration. The original narration is 40K-ish. So now we break it into, 10 segments, which your plan is like 4,000 words. Nowadays, you can definitely just do it in one shot. But at that time, I think the open source model they were using just couldn't do that. So we get the 10 segments, and now we use GPT-4 to summarize each segment. So now you get a one sentence summary for each segment. So now you get a 10-sentence summary for the whole story. And now basically you prompt GPT again to rewrite that 10 summarized sentence into a cohesive paragraph. Because the previous generated summarization, there could be missing context and missing information that's not a cohesive paragraph. So basically rewrite the paragraph in ages, story opening in 10 sentences or less, and keeping all the names and avoid it being replaced by footnotes. That's important because that will affect how we are grabbing the visual, because we need all the names, we need all the places, we need all those being spoken out so that you can do a very good video retrieval. It's just one tiny detail. And finally, usually these teaser feature an ending portion. So, think about the teaser about music. It's like maybe the end is like what we do with some of these AI music generators, or something, some question that just provoking your thought provoking, so that dragging into looking into the whole video. So that's essentially what we are doing. So but will the animals share their secrets with us humans? That's the documentary about a specific monkey. Cool. And so we also did a tiny experiment just to see whether they are actually working in this way. If you don't do anything like this, you will get a slightly worse, subjective test on polarization, informativeness, engagedness, even though you just see that. It doesn't reach statistical significance, probably because our case study is too small. But from the numbers, without looking at the error bars, it's doing something that at least is proposing in this question, and hopefully it's a better cohesive paragraph.
Is there any algorithms or heuristics in terms of segmenting the 10 segments, or is just equal lengths?
Equal lengths, yeah. Cool. Yeah, and equal lengths, but you have to take care about the sentence. You don't want to count. Oh yeah, sentence. Yeah. So for now, it's just yeah. And so that's actually a good sort of like an assumption of the model that information kind of uniformly distributed into these. And again, I guess nowadays we don't actually need to segment it. You can pretty much just pump the model, just do it in question. So I guess that would be better, or I don't know, maybe not better, but who knows? I guess there are options that segmentation is not the must, I would say.
Yeah, and sometimes the YouTube videos have chapter tags associated.
Yeah. So that could also be helpful, but basically what we are doing here is assuming that information is uniformly distributed in the different sections. Yeah. Cool. Cool. So as I said, this is the whole process is about, and the main thing we are learning is about the narration video matching. So likely for machine learning folks, what I'm going to talk about now is maybe not that machine learning intense, but this is like a first step toward AI assisted video editing. So the first approach that we are trying is that we actually still don't want to train anything. We're just looking into, well, we have nowadays many pretrained models that can do very good language and video correspondence measuring. So think about clip. Models like that, you can actually sort of understand, look at the video, but sort of get a semantic understanding of what that video is. So what we are doing is now you have a bunch of synthesized narration. So each of those like one sentence, and these are with different duration. And that's what all the trouble is coming, is you have different durations, and now you are grabbing different amounts of visual to pair with that specific sentence. So take it. For example, we have the sentence. We want to see what are the most suitable visuals to pair with that. So likely you can guess what we are doing. So basically, you just grab a pre-trained pre-trained vision language model, and you just going from the x-axis is from the first frame all the way to the last frame, and then you compute the clip score with the text that you have. So now you see some of them are very low value in clip. That's like, not very, I think I have this. So you can zoom in and you see that, this is talking about John and Mary on Earth, a nearly 10-foot tall abandoned Sphinx statue. So, this is like a bad corresponding visual, and those are a better corresponding visuals. So basically, we're just like adjusting the threshold so that you get a bunch of visuals that's connected to one another. We will set a threshold on the minimum length that you get. If you don't do that, you will get a bunch of one frame, and it just change over time too frequently. That's very bad for the user experience. So basically, you're finding the optimal threshold so that you grab a bunch of videos that together sum up to the desired length. And so that's essentially what we're doing here. Nothing trained, leveraging existing pre-trained vision language model, but still you can do a very good retrieval. And we also explore a learning-based approach using deep sequential models. Of course, we should do something machine learning and see how it works. And spoiler is that it turns out it's not actually better. But anyway, we could try, and hopefully there will be some way we can make it better. To think about this way, this is the deep sequential models that we're thinking about. So you get a bunch of sentences. So these sentences are the sentence you saw here. And now you just put it into this sentence embedding. So you can compute all the sentence embedding for each of the sentence. And what you want to do is not just the sentence embedding, what you want to do is to convert into the image embedding so that you get the image for that particular word. Actually, these are at different time points. You will have a sentence that lasts for 3 seconds, or the second sentence just lasts for one frame. So the sentence will be very in length. So you basically just grab the corresponding number of images to pair with that specific sentence you are going to do. So basically, we just train this model. There's this diffusion prior. You're familiar with the DALL-E 2-ish model, where you have this clip text embedding to clip image embedding mapping. That's basically what diffusion prior is doing. So we can actually leverage that diffusion prior, and we are just adding additional information on top of that. So not fine-tuning, but more like adapting or based on what we get from the diffusion prior, and can we add something more so that you get a better job. But anyway, once you have DC image embedding, you get a bunch of clip image embedding. That's not on the animation. Anyway, forget about the other part. Now we have a bunch of image embedding. We have the whole body content. Now we are, again, doing that retrieval thing. So what we want to do is that we compute all the clip score, clip embedding for all the video. And now you want to just do nearest neighbor decoding. So given each of the image embedding, look at what's the closest text embedded. The closest image embedding, because the generated image embedding might not be exactly what you have in your data set, but it should be close enough. So you find the closest one. And there's a tiny thing about smoothing mechanism so that it won't get changed too frequently. But it's just some algorithm thing to avoid things get changed too frequently. But this is basically what the learning based on algorithm is about. Questions? Yeah.
I'm kind of wondering if you could give some intuition for in what manner the learning-based approach is less successful than the one that you provided earlier, or if there are any strengths for this approach. Like, what do you see in the quality of the teasers that you get?
That's a good question. I mean, so one of the biggest feedback we get from the user side is that people just don't like frames getting changed too frequently, and that's one of the big things. And it's actually like strongly correlated to the final overall rate. And we found that there are some different metrics, and the biggest thing is about how frequently you change a scene. So there is an optimal number. You don't want it to don't change at all, but you don't want it to be changing every single second. So one thing we found for this learning-based approach is that it will oftentimes just keep changing the image embedding, and that's why we have the smoothing mechanism. But still, with that smoothing mechanism, we couldn't fix the whole problem because there are some limitation. Once you get the image embedded, so want to respect that, not just like completely, just replacing it with your algorithm. And that's also why this learning-based approach, we think it's not a one-shot solution. There are also a lot of like post-processing, and we could just grow. But at the same time, this model is also very hard to learn that the text to image embedding. One of the complexity here is that potentially you are sending 3 same sentence embedding, but somehow you're expecting the model to get potentially different. Think about if it's like a 10-second like sentence. It will be the same sentence embedding all the way, but you want to generate, say, 3 scenes for that 10-second. So think about like pretty much what the model will do is just updating the same image embedding. So you want some specific loss function to promote difference between corresponding frames, but at the same time you don't want it to change too frequently, and that's one of the things that we explore in the loss function. So we have some loss term to do that, and it's very hard to balance them. Cool, and we can look at the result and get some numbers to let you see how it goes. So this is a way to look at it, but we also have video later, but I think video would be very tricky to show today. So this is the ground truth, what you can see, and that's the TeaserGen PT, the pre-trained one, and the learning-based one. Anyway, we'll still try to play it.
Under the scorching Egyptian sun, Dr. Zbigniew Shabransky led a team of archaeologists in Luxor, meticulously excavating the unique temple of the revolutionary female pharaoh Hatshepsut. The air buzzed with excitement as John and Maria unearthed a nearly 10-foot-tall abandoned Sphinx statue at one of Egypt's largest archaeological sites. Meanwhile, in Aswan, Martina Bartanova's team stumbled upon ancient human remains that could halt their exploration of an unopened tomb. The discovery of a child's remains and a miniature sphinx added layers of mystery to their quest. At Karnak Temple, John and Maria delved into inscriptions, revealing Hatshepsut's portrayal as a male pharaoh, while Yale professors used digital technology to study ancient texts. In Dra Abu el Naga, another team meticulously organized fragmented human remains, uncovering stories of women in ancient Egyptian society. American archaeologist Suzanne Onstein explored.
Stop there. But you can see that there's definitely some visual, text to visual corresponding, especially if you see the human remains, you see that the visual, there's a sort of delay here that you get the idea. So this is the interval based.
Under the scorching Egyptian sun, Dr. Zbigniew Shabransky led a team of archaeologists in Luxor, meticulously excavating the unique temple of the revolutionary female pharaoh Hatshepsut. The air buzzed with excitement as John and Maria unearthed a nearly 10-foot-tall abandoned Sphinx statue at one of Egypt's largest archaeological sites.
You definitely see that it's working to some extent. I hope I convince you.
Under the scorching Egyptian.
And there's also some example, but I would skip for the time. This is another story about,
The vast theater of the cosmos, where stars dictate the destinies of their orbiting worlds, Earth has long danced in harmony with its sun, basking in the perfect conditions for life. Yet, this celestial waltz is not eternal. The sun's inevitable transformation into a red giant will one day spell doom for Earth's habitability, swallowing the inner planets in its fiery embrace. In the vast theater, under the scorching.
Yeah, I messed up with this, but anyway, so these are some of the objective evaluation that we are trying to do. Very hard to evaluate this because there's essentially no way you can evaluate, but there's still some metrics we can compute and look at, whether they correspond to some subjective evaluation. So one thing is about F1 score, even though it's a little tricky to think about what you're essentially doing. You have a 30 minutes video, and then you want to create a 3 minutes or 1 minute-ish teaser. Well, the best you can do is 1.88, but still, the F1 score is much the highest in our case, especially for the learning-based model. But still, a higher F1 score doesn't mean everything. And we have the repetitiveness. Some of the model just keep repeating the same thing again and again. And for the ground truth, it's only 7-ish, that it won't repeat the same, visual again and again. And all the audio models is like in 20, 30-ish. So definitely, we are still a little bit far away from what the ground truth is. And scene change rate, that's the thing that I talk about that's highly correlated to the subjective evaluation, where too frequent scene change is definitely bad. It will just completely ruin everything. So that's something you need to sort of think about the hyperparameters, think about all the parameters to have it controlled in a certain ratio. So you can see that the learning-based one have a higher scene change rate to the pre-trained one, and they are both higher than the ground truth one. So that's part of the reason why PT, the pre-trained one, eventually get a better score on the subject disciplines.
Yeah. Do you pose any limits on how many minimal successive or consecutive frames you retrieve? Because if you identify one frame that has a high score matching, and if you just retrieve that but without neighboring frames, you could have a lot of scene changes.
Yeah, we didn't do that, and that's kind of was impossible because we cannot do the same frame again and again, so it will be a video, and the video won't be still image, so it will change over time. So a 10-second video, it's probably unlikely to stay on the same thing for 10 seconds. So what we found is that from the model itself, that 10-second, think about, you're shooting a specific subject and you just move over it, there will be only part of it that's, directly facing the subject. So that part will have the highest score. So that matching score will be a curve so that you are finding the topmost.
Yeah. So when you find the topmost and then the rest is a curve,
And
then
those are
how wide this curve you take as a whole clip to.
So we changed the threshold so that it matched the duration that we have. So
Okay.
it's automatically determined. And most of the case, the sentence is not that long. The sentence won't be longer than 20 seconds at most. And most of the video clips, they won't stay at the same time for 10 seconds.
Okay.
So it's so many moving subject at the same time. It's like, well, you have so many different videos, and you are fighting the threshold that only grab the highlights of that video. So all together will lead to a reliable algorithm, at least that's what we found.
Then for one sentence, do you assemble multiple clips?
Multiple
or-
clips,
Oh,
yeah.
okay.
It could be just one clip, but it could be multiple clips, depending on, potentially we get very good, like 2 frames in this part, very good 3 frames here,
Okay.
good 3 frames here together, like 10 frames, then 8 frames. Yeah.
I'm curious to think about, does it make sense to like speed up or slow down clips to fit a sentence? Because I felt like I saw it in one of the examples.
Yeah,
but I don't-
that's actually our algorithm error.
Okay,
like,
awesome.
Yeah, so we didn't do that, but that's also likely something we do. Even though I'm not sure whether that's something, video creators do, but if that's, think about animation, then likely that's doable. And yeah, so that's definitely doable. Yeah, but in our case, we're just assuming the same way. Cool, we are running out of time. Check out papers for more results, and we also have a subject evaluation. So basically, what we found is that the proposed system is definitely working and doing a better job on the baseline models, but also comparing the 2 models that we have, the pre-trained one is doing a better job for the learning one. And what we dig into it, what we find is that the scene change rate is the defining, factor of what affects the final, likeness from the user. Cool. We also have some zero-shot samples and, TED Talks. Think about it. It's a bit tricky because, it's basically the same person talking about the same thing. So when you're doing that retrieval, for the clip model, it's just, a person talking about something. So, that present a very unique challenge here. And we will see in the next project how we can potentially fix it a little bit. And for all movies that definitely show the first limitation that we have, we assume that narration plays a more significant role than teasers. This is basically the biggest assumption in our case. So that doesn't hold for movies or vlogs where you basically tell the story from visual rather than the narrations. But also you can match interview scenes, and that's exactly what we've been doing in the next project, allow a model to hold an interview. And finally, it's a one-to-many mapping. So like all the Gen AI thing nowadays, at least at the beginning, F1 score could help in determining whether you're actually doing something, but later on, this is essentially a one-to-many mapping and generate the process. And one of the benefit of the proposed system is that, it's actually generating more like a script that where you can edit it later on. So it's not, like a base output that you cannot change. So there's, multiple different matching clips that you can choose from and adapt from rather than, it's just a one-shot generated result. Am I running out of time? Kind of.
Oh, we still have 10 minutes for Q&A.
Okay, there's another project.
Oh,
Yeah.
okay.
Should I just rush through it, or we should just, we could just give you a hint?
We can give a teaser video.
Teaser video. So what we are trying to do, this is a nice slide, I guess. Learning to code a video. So this is what we want to do. So this is going beyond the TeaserGen model, the work that we are doing. So we can transcribe this video, and you will see that there's narration, there will be interview, narration, interview. And we are thinking about, can we learn to quote a video in your script? So what we are trying to do here is that in the studio story script, you will basically just talk about stuff, and we try and fine tune the LLM so that it can generate this quote special token. And later on, we will determine how you get the quote. So for the everything else, not the quote part, you just do the same thing as what we did in TeaserGen, you TTS, and then you get the frames. But now the interesting part is about the quote. So you grab the quote, and then now you use the quote. So now you have all the original long video, and you cut it into so many different clips. And now you have a bunch of different clips. And now you're thinking about how you can get the best quote and just grab that, put it into your story. So this is different from TeaserGen, because TeaserGen, basically you are rewriting everything in your TTS all the way. But now we are thinking about, we call it retrieval-embedded generation. So basically what we're trying is to, think about if we can do a better quote. So I will just talk about this. So, you have a quote here, and what you are trying to do is to generate the quote part, and you want to generate a sentence for that quote so that you can later use that to extract what you have. So think about what's going on this, the model's mind is that where you're writing something and then you think about, well, you should get an interview for someone talking about something. And so you have a quote placeholder, and you are trying to see what that quote should be talking about. And potentially you can find it in your space, extracted quotable video clips that you grab from the original long. So basically we can just use that and then just do some, process similarity to do the retrieve. Well, I just skip over these. So I can give you a quick example. You can definitely see that the model is actually doing some quotes. So these will be the quote rather than the narration.
The crisis has given me a lot. I've never before seen rents like they are right now. Lacks of money has opened up these opportunities for people like me to rent apartments in the city for such cheap.
Is very free, very free. The down economical level and the big freedom that we enjoy here in Athens gives you the point that you can do whatever you
have been through a lot of crises and a lot of problems, and we are not like North Europeans where we expect the state to come and take care of us. This has never been the case in Greece because on a government level, it has never been very successful, let's say. So Greeks are kind of used to doing things by
to get a sense. So now we have the ability to actually quote something rather
Crisis
than
it's dazzling. Early morning.
something generated by the narrations.
I'm going.
We also have a bunch of evaluation, of course. I'll just keep those. And I would say something to sort of like conclude that. So the whole video editing is about combining multiple footage, and I think the REGen project that we're doing is very important because it allows for the first time we can extract existing footage and put into your story, and that storyline is still cohesive. So why that is important? I'm thinking about this multimodal RAG-based video editing. So think about this is what video editors always do, or video makers. They will shoot a bunch of different footage, and then will say talk with a multimodal LLM, where this multimodal LLM, the goal is to generate an editable video script where you have, say, this is the narration. Now we insert an interview with all the timestamps and what the details about those narration and interview. And hopefully this multimodal LLM will be, contextualized with that, all the raw video materials available, just as, video editor are looking at all the video materials and try to compose the story. And then you use the video retriever to actually render the output video. And so that's important because I think that's the way how we can potentially have Gen AI model integrated into video editing software, where you have this timeline and that's essentially what you can generate with the LLM, and then they are connected. They're essentially the same thing, just in different format. One is in JSON-ish format, but one is represented as the way how, existing creative workflow is. And I should skip this first. So, we are going from retrieval augmented to retrieval embedded generation. Can an LLM learn to quote and embed the quote properly? How to quote materials in other modality, in our case is video, but think about audio, image, videos, music. So all the different modality, it's essentially the same idea. You are retrieving, but you are integrating those, embedding those material into your story. And so we need a good retriever to identify candidate portable materials, but at the same time, you need a multimodal LLM to understand all the data so that you can incorporate those materials and embed them. And how about music? I think it's the same idea for music, integrating Gen AI into music creative workflow. Unfortunately, it's very hard to get all the, session file in those. So this is a typical DAW. You have all the different sessions, but think about it, it's just similar to what we have in the video editing part, that you have all the script, you have, the plan, you see that there's something going on, there's a planning going on. And can you edit those? Can you have the AI propose a new session, or can you automatically use LLM to sort of like arrange music on top of like an editable, high level plan so that you can the musician can step in and work with the same music influence. Cool. I have time to talk about research on music. I guess I'll just stop there. And so these are some of the things that I'm most interested in on modern AI for content creation. Human AI co-creation tools for music, audio, video creation, and of course for music examples I'm most interested in, and that's why we're doing this next video. We are AI slowly starting using in Michigan. We are organizing a workshop in New York. So if you're coming to New York, definitely come join us. With that, thank you so much. And people like fantastic for our videos.
Yeah, thank you for this phenomenal talk. Yeah, folks who have to go, feel free to go. But I think if nobody's kicking out of this room, we could stay for another 15 minutes, maybe for a Q&A.
I guess like the question I have about your work is that if you want to expand from summarizing documentaries and being able to work with full video corpuses and stuff, I'm kind of wondering what are some of the limitations or challenges that you foresee when the content mass of videos you have to go through becomes much larger?
So one thing you mentioned about the large content of that, so scalability is definitely it. And we do that. So think about now we are potentially working with a huge database of potential clips. That's sometimes happening because think about especially in music case that we have a sample pool that just you have all the sample bank. It's just tremendous, enormous amount of pool of samples. How do you grab essential ones or fit one that fit into your composition? So that's the same in videos, and I guess retrieval is definitely part of it, but how do you get a contextual representation of the video clips? So one of the challenges that we see is that some of these video clips, if you grab them in like just one scene, it's actually talking about something beyond that particular video clip, especially in the multi-video editing case. So you need to contextualize embedded for that particular video clips that sort of know what the subject is and you want more information. And so I think that will get a better model. And there's another big limitation where the whole REGen thing can work is because we are using speaker diarization to get the data. So if you just apply Whisper, think about like a lecture recordings, everything would be the same person. There's no way you see where the slides change. So now we are getting those interview clips because this is speaker A, and speaker A would be the narrator. So it will be speaker A for 80% of the time. Whenever you change the speaker, if you use speaker diarization, you know where those clip insertable, quotable clips are. But that will be kind of challenging lecture recordings. We also wanted to do something about lecture recordings and couldn't have time. Talk about it because I'm very excited about it, even though I don't know how exactly we could do it. So I'm imagining about this work. If you're interested, we can together think about how we can do it. So lecture recording, we have this lecture recording. So oftentimes you know, you are looking at it, at least when I was in PhD or, you know, even before college, I would like to just review the concept of one specific RNN, and then you have 2-hour recording. What to do with that? You use something like REGen to generate a short summary that's just focused on the specific, idea that you just asked about. And the benefit of having that LLM is that you can actually have a loop. And now you can, ask more about now, oh, actually, I know about what's RNN, now what's the math? And there will be other position of that. And that's where, this retrieval-embedded generation is important. Because now, you likely, if you're looking at the lecture recording, you're likely wanting to know what, your professor or instructor is talking about, rather than, well, this is just a, LLM or asking Google, Gemini, or ChatGPT to answer your question. But now you are looking at your regional recordings. So that will, create that, embedded with the original lecture clip embedded here, embedded in the generated shorts. So it will create, at least it's the actual content that's being delivered in class.
Thank you.
Sort of,
Yeah,
it's an extension, yeah, but I guess that sort of also hints out why it's important that way. Yeah.
Yeah, thanks for the talk. I was just wondering a bit about like the performance of the model. Like, do you see it as something that like you could put into an editing program like Premiere or something like that? As in like, is it like performance wise close to game time ready? Do you feel like there are steps in the background that could be done in terms of like analyzing footage or something like that? Or do you feel like it's still like a while away for that?
I think definitely it's something. I mean, I wouldn't mind looking at it, especially if there's a very long video about something that I just want to get a sense, or even think about teasers. Like, Netflix actually have those randomized teaser when you hover onto it. So this sort of creates something very good for that. I guess hopefully this could, extend to more, documentaries, more knowledge-based content, so that you can still get a sense, think about even like AI summary for Zoom recording. Now it's not just AI, like text-based summary. Can it be, like a condensed version of the whole things? And think about news are actually just in the exact form. Like you are talking about a situation, a real life activity. Now you want to narrate it and at the same time grab real footage into it. So news is actually one of the final output that we are seeing in this framework. And that's where, these real footage matters.
Are you also?
Yeah, I was also I didn't. Yeah, I was also asking about like also the speed of at which.
Speed?
Yeah, like how compared to real time.
Everything here is fast.
Awesome.
Yeah, I think we are sort of like budget, very computationally bounded. So that's also a benefit. I perceive in all my research. I've been using very small amounts of GPUs for all my research. So yeah. It's very time powerful. Mostly pretrained models and ChatGPT. I guess it's large, but if you prompt it most of the time, it's relatively not possible by inference.
Can I ask a follow-up question?
Sure.
How much does like one of the trailers cost to generate, for example? Do you happen to know?
Cost? I don't really know. I mean, but you will have to prompt GPT. If you're just prompting it once, then you can get a summary. And pretty much that's it. And then I think the biggest cost is finding the clip image embedding for the whole documentaries. So that's one of the biggest, that's the most costly step. But once you've done that, you can store it, and pretty much think about this vector key thing. Is like whenever you're typing, you are actually just matching those. Think about it sort of like a fingerprint of those each individual clips, and you are just retrieving from that. So I guess to scale it up, there will be a lot to be done on getting a very compact embedding to represent each of the clips, so that you can determine whether it fits in your case. But that will be sort of like an optimization retrieval. But for now, running the clip through the whole video is this development.
Yeah, sorry, yeah. I also just noticed in the quote like version, I don't know, is there any like future work or like directions about like how you might improve? Like it felt like the quote ending points weren't like as neat as like maybe in a professional trailer, someone might actually like give like the juiciest part of a quote or something like that. So I was just wondering kind of about like um how you're thinking about like maybe improving like maybe not even just that, but just like what are the next steps for
I think that touched this slide, but we could talk a little bit about some of the limitation of the code one. So again, it's the same, like narration plays a more significant role, even though it's slightly less than the one that we talk about in TeaserGen. So we actually investigate how to use multimodal thing when you are doing the retrieval. Eventually, you also want to use the vision in addition to text, even though in our case, still not working to the most part, but still, I guess there's a long way to go in actually having this multimodal embedded to work so that you get a better retrieval. So there's another big issue of this is that the risk of misplacing the code in the wrong context. So this is inevitable sort of like the question, the issue, and it's also the same as how you see some of the fake news or misinformation on the social media, where they are actually saying that, but you put it in the wrong context. You put it with the wrong surrounding narration, and it becomes something else. Or you put the wrong names to a specific person that they are actually not. They are talking about that, so there can be some risk on that. And so in our case, we were just using this clip. The clip is not the end. Can we grant the script generation model with information about all quotable materials? So this is important because when you're generating the script, you want to know what are available. There's a case where you generate a quote, and so think about I want an interview with Trump. How do you get that? So even though it will be nice, especially if it fit into your story, but still you want something that's available in your database. So that's one thing we didn't investigate here. We assume that the generated quote, most of the case, it can find something close enough in the pool, but still, if the script generation in day one, they could already know what are the available materials. But there will be a lot of more, sort of like RAG-ish, a multimodal one to do it so that provide more context. And context aware video embeddings, I just talked a little bit about it. So the video clips need to know the surrounding information. It should be contextualized rather than that's video clip standalone, because that's where all the misinformation could happen. Where maybe they are not talking about the exact subject that that they are talking about just literally, but it's more on depends on the context. And yeah, seeing segmentation, we also talk about it. So these are some of the limitations. So we are totally not done yet. I think there are so many things, but this is sort of like the first step. And long to short video generation is assuming you have the long video as input, so you slice it, you get all the materials, you arrange it. But now think about in this case where we are just grabbing a bunch of raw materials. Think about your video creators, your filmmakers, you shoot a lot of raw footage. Then it becomes much trickier because all those footage can be super long, and there will be only part of that you should use it, and you have to determine how long it is and how you connect them together into a cohesive story. And that story could depend on the user prompt. So I guess there's a lot more to be done, especially in video editing. But long to short video editing, we have some learning-based method to explore because we have some kind of data set, and it's somehow more like you have some ground truths. Indeed, teaser, likely you have to talk about, summarize a little bit about the whole the video. But now if you're thinking about AI assisted video editing, or think about AI music generation, what's your intention? What's your input? How can you control the model? Then that will become the big issue next. Yeah, but I guess hopefully this is like a starting point so that we actually look into grabbing real footage, arrange them, and then compose rather than just purely generating new videos, new image, new content. That's most of the Gen AI models that we are looking at nowadays. It's not essentially what creative workers creators are looking for.
How long do you think it will take before we get this video editing assistant where you give it raw footage and it gives you an outline for a documentary?
I think we're far away from that. I think yeah, I think for video, there is a lot of data set. I mean, we are using teaser because it's a little bit easy, but I guess there's a lot of like video understanding models that we can do segmentation, you can do summarizing, we can do captioning. So I guess we have a lot of foundational work that can annotate a larger data set so that you can do something like that. And yeah, and video still more, there's no parallel thing going on, unlike music. So music, multiple instruments, you have sessions, you have, different parts going on. So that's a little tricky, you need the session file. But for video, I guess, looking at all the video available, you can do scene change, still tricky, but there's some way out. And I think annotation is costly, but still we have semi-automated way to do it. So I don't think we're far away from that, just people have to sort of realize. And that's why we are proposing here that, video editors are editing real footage rather than just wanting some new AI generated visuals. And well, just put it somewhere, but still, surrounded with real footage. How can you combine those? And potentially, AI generated footage is also important. That should also be part of this, retrieval thing. You generate AI footage. If you couldn't find that particular footage that you want, should we generate it? So, there's also all sort of different way, retrieval, generation, but all at the same time, they should together compose the pieces. Yeah. Hopefully we're not far away.
Maybe a meta question. Like this is super exciting. I feel like there's like this feels like a startup idea, like because it's something really useful for a lot of people, and video editing has become so common. Like like every one of us is like
All content creators.
Yeah, we have some task on hand that requires video editing. And yeah, you were talking about kind of AI assisted video editing and kind of maybe working with video content creators. So I'm curious kind of in terms of your workflow, like how do you figure out like what part to prioritize? There's like so many different problems that kind of needs to be solved in this like kind of assisted situation.
Yeah. I guess most of these are based on my experience working, with like, working on some video projects. At some point, you have some sort of recording you want to submit to, to upload to YouTube and lecture recordings, and you will get to deal with that. And some of them, just grounded into thinking about these. And that's why I was looking at the video editing, video generation pipeline, and was like, it's not actually how we are doing stuff in Premiere Pro. But if you go to a website and then you do something, well, cool, you get a video and then you download it and put it into Premiere Pro. And at the end of the day, it's still in Premiere Pro. But now it's not, where to put it, what would be the storyboard? Can we generate something, that just fit into the timeline of Premiere Pro, where that's essentially what people are doing. And the same for music, the same for other, content creation. We think about how people are doing, how people are creating content in their field, and where are those formats can be transformed into, think about it, JSON 10 timestamp-ish script, and that's potentially a bridge to go from the actual software that people are using, the professional creators are using, to some of the AI models that we are familiar with, LLM, multimodal, retrieval, embeddings, things like that. Okay, we breach that. So that's most of the thing that I'm thinking about, and I guess that's what's most important, at least for me, to think about, so that it becomes something useful and be part of the AI creation workflow rather than it's a standalone single body generation. And one thing I didn't talk about, I mentioned that the music and audio part, we should definitely do that. So this is still content and video, and we just grab those whatever available. But think about the same framework could apply to the same situation. You will still have video. You will have the sound effects. We will have the music track. From long to short video, you still get those. You can separate that and get those and together compose the video. But think about, in this case where you don't have the input on video, still you have so many, music that you potentially are using. There are sound effects that you could be using. Can you retrieve them and then put them into the script that you have? Or potentially, if you couldn't find it, nowadays you have so many AI sound effect generation or AI music generator. If there's something you just couldn't find it, then AI could be a good, substitute for some of the most tricky situation. So it will be a hybrid system. I foresee, hopefully, in the future is that there's a spectrum between pure generation to retrieval. Retrieval is where you have all the pool of, stock music, stock image, stock videos. And on the other side, you have nowadays very good AI generation models. But somewhere in between is that, when you want very specific thing, now you want the generation model to take in. And if you want something just like very vague, very rough, something that could just help, then you can do the retrieval. But I guess in the future, we want something hybrid in the middle, where part of it would be AI generated. That's, for the tricky, very complex prompting. But for other part, we want to use real footage, real music, real audio effects to put it into the story. Far from that, but hopefully that's a start.
Yeah, wow, super impressive line of work. Yeah. Thank you so much for giving this talk and